Hello everyone, myself Dr. Vijay Lakshmi Edalli. Welcome to the class Alcohols. In the last video, we have discussed about classification and nomenclature of alcohols. In this video, we are going to discuss about preparation of glycol and its reactions. So you may remember what is glycol. Glycol is a dihydric alcohol which is also called ethylene glycol. Ethylene glycol is prepared by ethene by two methods. So one is hydroxylation of ethene. So when ethene is treated with cold dilute alkaline potassium permanganate. So what is alkaline potassium permanganate means? It is a mixture of KMnO4 and sodium carbonate. You may remember that you have used this reagent. It is very dilute KMnO4 and sodium carbonate mixture used for identification, that is in the organic spotting whether the compound is saturated or unsaturated. To test that, you have used very dilute potassium permanganate with sodium carbonate. If pink color disappears, the compound is unsaturated or easily oxidizable. And the same reagent is also called Bayer's reagent. When ethene treated with Bayer's reagent, it readily hydroxylated to form dihydroxy compound that is called ethylene glycol. Another method is ethene by heating in air at 525 Kelvin in presence of silver catalyst. In presence of silver catalyst at 525 Kelvin, initially it produces intermediate epoxide or ethylene oxide. Two methylene groups with oxygen which forms a cyclic compound called epoxide. This epoxide on hydrolysis in presence of acid or base gives ethylene glycol. So epoxide on hydrolysis in presence of acid or base gives ethylene glycol. These are the two methods, that is glycol is prepared by using ethene. Let us see the reactions of ethylene glycol. Here oxidative cleavage of ethylene glycol is discussed. So glycols when treated with oxidizing agents. So what are oxidizing agents? Oxidizing agents are the compounds or substances which undergo self-reduction and helps for the oxidation of other compounds. So they are called oxidizing agents. The compounds which helps for the oxidation are called oxidizing agents. So two such oxidizing agents used here are lead tetraacetate and periodic acid. So let us see the first one, lead tetraacetate. Here ethylene glycol on treating with lead tetraacetate, it undergo oxidation. So this carbon-carbon bond undergo cleavage. Both the carbons or this CH2OH undergo oxidation, gives formaldehyde. Lead tetraacetate undergo reduction to form lead acetate and produces acetaldehyde. So here ethylene glycol on oxidation with lead tetraacetate produces formaldehyde. Lead tetraacetate undergo reduction to form lead acetate. So this is redox type of reaction. Then how this reaction takes place? We can see the mechanism. The reaction is initiated by the formation of 5-membered cyclic ester intermediate which undergoes oxidation reduction process resulting in the cleavage of carbon-carbon bond. So this carbon-carbon bond undergo cleavage So initially ester is formed here. So by removing one acetic acid, here hydrogen is replaced and lead triacetate is added. Next, a cyclic compound is formed by removing acetic acid. Carbon lead bond is broken. The electrons are given to carbon oxygen bond, and this carbon carbon bond is broken. The electrons are given to carbon oxygen bond, so that this oxygen lead bond is also broken and it produces lead acetate, and these two becomes formaldehyde, HCHO, HCHO. Two molecules of formaldehyde are produced. Second one is oxidation with periodic acid. So in this reaction also carbon-carbon bond cleavage takes place. Oxidative cleavage of glycol with periodic acid takes place again through cyclic intermediate. So here cyclic intermediate is formed. From that oxygen iodine bond is broken. The electrons are given to carbon oxygen bond, so that this carbon-carbon bond is cleaved and that electrons are given to carbon oxygen bond, and this oxygen iodine bond is broken. The electrons are given to iodine, so it produces two molecules of formaldehyde. Two molecules of formaldehyde are produced. In both the reaction, glycol undergo oxidation with oxidizing agent and produces formaldehyde. Another one important reaction, that is Pinacolone rearrangement. What is Pinnacle? The ethylene glycol. So here in the ethylene glycol, the carbon having two hydrogens. Carbon having two hydrogens. Both the carbon are having two hydrogens and one OH group to each. So Pinnacle is completely substituted 1,2-diol. So here it is substituted with two methyl groups. Both the carbons are completely substituted. So this is a Pinnacle. Pinnacle undergo dehydration with the removal of mole of water. So here a mole of water is removed in between them, and one of the CH3 group is rearranged and it gives methyl tertiary butyl ketone, which is called Pinacolone. So with the dehydration it undergo rearrangement. So it is called Pinacolone rearrangement reaction. Let us see the mechanism of this reaction, which is important reaction in this chapter. So Pinacolone rearrangement. This reaction, Pinnacle, among that one OH group is protonated. So the oxygen containing lone pair of electrons, both the OH group, on that the oxygen having two lone pair of electrons. So one of the OH group is protonated. So here it is protonated. For this new OH bond, a lone pair of electrons are used. Therefore, oxygen gets positive charge. In the second step, this carbon oxygen bond electrons are given to oxygen. Therefore, the bond is cleaved. Water molecule is removed, H2O. So for that, this carbon loses electrons. So it becomes carbocation here, C+. When this carbon it gets a positive charge, it becomes somewhat unstable. So that this carbon oxygen bond here, lone pair electron present on the oxygen are given to carbon oxygen, and carbon CH3, these bond electrons are given to CH3. This CH3 reacts with carbocation in the third step, that is rearrangement of this methyl group takes place. The methyl group is shifted to carbocation so that it produces OH with this methyl group is the methyl group present on this carbon comes to the alpha carbon now, and this becomes double bond OH. The oxygen loses one lone pair of electron, therefore it gets positive charge. Now the OH bond electrons are given to oxygen, the CH plus is removed. So initially in the reaction beginning H plus is added, at the end of the reaction H plus is removed. When a proton is removed, it becomes C double bond O, which is called Pinacolone. So with dehydration, along with dehydration, rearrangement also takes place and it produces a ketone which is called Pinacolone. So this reaction is Pinacolone rearrangement reaction. So I hope you understood the mechanism of this Pinnacle and Pinacolone rearrangement. That is simple dehydration in the first step, and next it undergo rearrangement to gives Pinacolone. A ketone is formed. Tertiary methyl tertiary butyl ketone is formed. In the next class we discuss about the trihydric alcohols. Thank you.